Hey guys, so welcome to BlockBase. This is the first technical video that we're going to be making on our series of technical videos about BlockBase. So this YouTube channel that we're doing here is to explain how BlockBase works, how you can download the software, how you can code on the software, how you can do your queries and so forth. So we're going to traverse all the details about BlockBase, so you developer guys can use it with ease and can sit in your couch and you can learn how all this stuff works, and then you can see how easy in some cases it is to run BlockBase. So this is the first from many presentations we're going to be making. Some will be in depth, where we're going to download the code and play with it and compile it and so forth and execute it and run a node and run a network and so forth. But this one is just an overview of what BlockBase is in fact. So let's start. So if you like BlockBase, if you've heard about BlockBase, and if you want to learn more about how BlockBase works in depth, subscribe to our channel and hit the bell icon so you get notified every time we do a new video, and hit the like button. That will be also a great help for us that are doing these videos for you guys. Okay, so first things first, what's the goal of BlockBase? So we aim to create a global service for secure database storage services using blockchain technology. So if you're a developer and if you use a traditional database to store the data for your applications, or if you use a cloud service like from Azure or Amazon or Google or so forth to store your databases, you could consider changing from those systems to BlockBase, because BlockBase provides a service for the distributed storage of databases. And from a technical standpoint, from a developer usability to use the technology, is very, very, very similar to a traditional database. So if you know SQL, you can transition very easily to BlockBase. Okay, so why did we build BlockBase? What's the motivation behind BlockBase? So one of the problems that we're facing nowadays is that there's a lot of fake information everywhere. So you've got fake news, fake profiles, fake sites, fake statistics, fake photos, fake videos, fake everything. For example, the image in the center there with all the faces, all those faces were generated by a computer, right? So it's from people that don't exist in fact. So there's a problem right now with fake information, okay? So another big problem at the moment is with cyber attacks. So a lot of information gets stolen and sold online and gets manipulated and instructed every year. And this has a huge cost, estimated at about 2.3 trillion every year. And it traverses a lot of different sectors, but mostly, as you can see in this chart here, it affects businesses, right? Medical data, education. So these are very, very important sectors where cyber attacks have a big impact on the data that's being stored there. So this is a big motivation to create a system that tries to solve these types of problems, okay? So to give more detail about these attacks, so 90% of the information that was stolen, changed and so forth had sensitive information. 90% was in business, health, government and banking. 50% of the cases, the people that were storing the data, like the tech guys, said it's too hard to do proper security. So there's a big problem with doing security. 70% of the cases, they didn't use any type of encryption. So if the data was hacked, if the hackers had access to the database, everything was open, right? And they could steal all the data that they want. They could manipulate all the data and so forth. But the most important statistic that I see here is the next one. So 30% of the cases, so 1 in every 3 cases, it involved inside actors. So people that belong to the teams that were supposed to protect the data and respect the data and honor the data, they were using the data in their benefit, right? To change it, to steal it, to modify it, to delete it even. So this is a lot. So 1 in every 3 cases involves an inside actor. Is huge. And usually it took about 200 days to find the data breach when it was found. So many cases, it is never found. We never know it ever happened, right? So there's a big problem with computer security and with data security in general. So the big question that arises from all these problems is how to ensure the security and especially the truth of our data. How can we ensure that, since we've got all these problems running around? So all this data theft and change and so forth, and fake data and so forth. How can we ensure the security and the truth of data? And clearly, the traditional systems are not secure. So they are really not secure. Otherwise, this wouldn't happen. So what do they not ensure, these traditional systems? So they do not ensure confidentiality. The data that is stored in traditional databases, here I'm going more into the direction of databases because that's what BlockBase is all about. So traditional databases do not ensure confidentiality in the sense that the data that you store there is not encrypted. You can use encryption mechanisms provided by the database technology, but that encryption is done in a centralized way. That means that the database itself has the keys to encrypt and decrypt the data. Also, it means that all the data that reaches the database has to pass through a system that has been built, like a web application, so forth, and it enters unencrypted, and then it enters the database unencrypted, and the database will then encrypt the data. It also means that a system administrator, a database administrator may have the keys to decrypt the data and access all the information. So in fact, there's no confidentiality of data. It's like a fake confidentiality, a fake privacy of data, right? So you also don't have integrity of the data. You don't know if the data was changed, if it was manipulated, if it was deleted. So if you've got an audit on a database from a company that has been doing like shady stuff, the company could at the last moment go to its most important data and change it so it looks good for them, or delete it so it looks good for them. So you don't have integrity with traditional databases. You don't have history. So when you do stuff with a traditional database like inserts, updates, deletes, and so forth, what is done, and that's what remains in the database. You can have like a history log that you built on the side that records all the changes that you did to the database. But that history log can also be manipulated, can be deleted, can be disabled, so forth, right? So in fact, you don't have real history of all the changes that you do to a traditional database. You also don't have accountability. So usually, most systems that interact with a traditional database have one or a few accounts with, in many cases, with a lot of privileges to do changes to the databases, right? And if someone uses those accounts to enter the database and to change the data, you don't know who did that. You just know that one specific account did that, but yeah, it could be done by many people, in fact. So you don't have accountability. You also don't have redundancy and access. And this is a little weird because you can like replicate a database. So you've got scalability. So in fact, you can make a system redundant, and that improves access to the data. But the thing is, that redundancy and that access is done in a centralized way. So there's a team behind it that centrally manages all the versions of the database, right? All the backups and all the databases that are currently running. So it's managed in a centralized way. So those guys that manages the database, that built the redundancy and the access for the databases, they can bring it down too. So in fact, you don't have real redundancy and you don't have real access to the data. So it's like a fake redundancy and fake access again. So traditional database systems, in fact, don't ensure almost anything. It's just a place to store data, but it doesn't have real security. All the real security is completely fake here. So blockchain technologies help in solving these problems. And this is mainly due to the characteristics of blockchain, from being a distributed system, from being a system that's append only. You cannot change the past of the systems. They are very robust, so it's different from a traditional database, a lot different, and has a lot of security built in from the ground up. So we're in the process of having digital transformation in the world, and it will definitely include blockchain. So in some cases in the near future, it will be mandatory by law, and we are starting to see this with health. So some governments are starting to push for companies that deal with health data to store that health data on the blockchain. So if someone dies or if there's a big problem related to the health of someone, you can be sure that the data is securely stored, like the history of what happened to that person is securely stored on a blockchain. Auditors won't accept data that's been stored on an Excel file or on a database when you have like these robust systems to store the data on, like blockchain, because blockchain ensures that the data that you store there cannot be changed, and Excel files do not, and databases, traditional databases, do not. So this is something to expect in the future. Using blockchain will be viewed as a mark of integrity and of quality, right? And we're already seeing big business incorporating blockchain. And we believe that in 1 decade, it will be as common as the internet, and companies that don't make this change will probably be left behind, similarly to what happened with the change of the internet. So, what do blockchain technologies ensure, in fact? So they ensure integrity. So data can only be changed by their owners. You have to own the private key to make changes to your data, to transfer your funds, right? To execute the smart contract. You have to own the key. So there's integrity there. Also, when you do something, it remains there, right? You cannot change something you've done. So that's a piece of integrity and a piece of history. So blockchain ensures history of data, history of operations. When you look at the blockchain, you know everything that happened in the past, and you have to know it in order to construct the blockchain from the first block until the current block. In blockchain, you have accountability because all operations are digitally signed. You can know who did what when, right? and you have redundancy. It's a distributed system, it's a distributed network, so all nodes store the same data and therefore is redundant. And it's not like a central redundancy, it's a distributed redundancy where any participant can participate on the network and store their own copy of the data. So what do blockchain technologies not necessarily ensure? They do not necessarily ensure confidentiality of data. So many blockchains enable you to store the data completely open on the blockchain. And that's a problem if you want to store databases, for example, of your business. So if you store them on a traditional blockchain, probably you'll have problems because the data will be public and will be distributed across the world. And that's perhaps one thing that you want to avoid. Blockchain systems usually have problems with scalability. So we've seen this happen with the Bitcoin network, and we've seen this happen with the Ethereum network, and we've seen this happen to some extent with the EOS network. So blockchain systems are scalable until they are not. So eventually a hard cap is reached and you cannot scale the system further. And this happens mostly because you have one single chain. It's the main chain, and everything is related to that chain. So all the nodes process that chain. So even if you've got a more distributed network or a more centralized network, eventually you've got a scalability problem because it's just one chain there, right? And there's also a usability problem. So these types of technologies are usually difficult to use, are difficult to learn. Usually it involves learning new programming languages and so forth, specifically for smart contracts in the case of Ethereum. So they are not easy to use. Okay. So in BlockBase, we want to use all the benefits of security that blockchain gives you, but also solve the confidentiality part and the scalability part and the usability part, and target the system specifically for the storage of databases. So how do we solve confidentiality? We built an encryption mechanism that uses up-to-date standards of encryption, where you can encrypt all data that you want to store on BlockBase. So your database name, your table names, your column names, your record data, individual record data. But you can do it in such a way that you can query it. You can fetch your records pretty quickly, even though they are completely encrypted. So you encrypt it on your side, and when you communicate it to the network, the data is completely encrypted when it arrives to the network. So the guys who are running the nodes from around the world will never see the true nature of the data. So the scalability part is done through sidechains. So BlockBase, in fact, doesn't run just one main chain. It runs any number of sidechains to a main chain. Now we are using EOS as the main chain, so BlockBase runs as many sidechains as needed to the EOS main chain. So let's say one company wanted to use BlockBase technology, then the BlockBase network would spin up a sidechain for that company, and that sidechain would be provided by a subset of nodes of the network. And in fact, the company requesting that sidechain would specify how many nodes it required. So for some types of sidechains, you want to have a lot of nodes because you need a lot of redundancy and a lot of security. And for other sidechains, you can request for a smaller number of providers, of nodes on the network providing that sidechain specifically. But you can have as many sidechains as you need, and all those sidechains are pegged to the main chain in the sense that every block that is produced has its block header signed by all the nodes that are providing that sidechain, and is published on the main chain, has its block header published on the main chain. So you've got a very strong main chain that gives proof that that block header existed, which in turn gives proof that the set of transactions related to that block also existed. So we solve scalability that way. Of course, the concept in practice is more complicated than what I have explained here, but we will go in depth in another video. Here you can get just an idea of the way we do it. So it's side chains parallel to one main chain. So then there's the usability part. When you've got this sidechain working and provided by many nodes, you can interact with the sidechain and use operations that are very, very, very similar to what you would do with a SQL database. The syntax is almost equal. So you can manage your databases in a very, very similar way to managing a traditional database. So you won't almost see any difference from interacting with the traditional database and from interacting with the BlockBase node. So that's how we solve the usability part. So going a little more in depth about what we've been talking about, BlockBase is very, very, very focused on security of data. And before BlockBase was even built, we had an idea of using blockchain as a way to secure databases, but before starting to design BlockBase, we went to the heart of computer security. And there you can find the pillars of computer security, which are confidentiality, integrity, and availability. And if you solve these three pillars of computer security, you've got real security. And again, the confidentiality is solved through the encryption mechanism that we've built that completely encrypts your data with standard up-to-date encryption mechanisms. Then you've got the integrity part that's almost completely given by blockchain technology. And then you've got the availability part that we solve with sidechains. So you have a system that is more available and more scalable. That's almost horizontally scalable. Okay, so what are the key benefits of running this type of technology? The first thing is just like an add-on. When you use BlockBase, you've got a ready built integrated explorer, so you can see all the side chains that are currently running, and you can see all the blocks that are being produced. You can see the entities that are issuing side chains, and you can see the providers that are there to provide the side chains. So you can have like a clear picture of how the network is at one moment. BlockBase has 3 years of research and 1.5 years of development and optimization. So we've been thinking about BlockBase for a long time now, and we've been actively developing it for more than a year. BlockBase was financed by the Portugal 2020 European program. So the Portugal 2020 program is a program that's under the umbrella of the Horizon 2020 program, which is a European funding program to fund cutting-edge R&D projects in Europe. And to apply for this type of funding, you have to write a very complex document, an extensive document with about 100 pages long, explaining everything in detail from start to finish about your project. And then that document is analyzed by a panel of experts that will decide if the idea should be funded or not. And it's really hard to get the funding. So we were funded, and that means that right from the start that there was an independent group of experts that thought the idea was very good and was worthy of getting the funding. The code of BlockBase is completely open and open source, so you can go there, you can look at it, you can download it, you can mess with it, and so forth. And also, it leverages the most advanced blockchain tech in the world, EOS.IO. So, platform adoption. How do we help in platform adoption? So, as I said, it's very, very similar to using a traditional database. It transitions easily from a one-node local network backed by an EOS.IO main chain to a fully distributed network. So if you want to play with the technology, you can start building a local network on your computer, and then when you're comfortable, you can expand and develop or use a fully distributed network, participate on the BlockBase network as a provider, and so forth. It can be tested online without setup at the moment, so you can go to BlockBase network /sandbox, and you'll find there like a development environment very, very similar to a development environment for interacting with traditional databases, where you can create there your databases and add data and update data and delete data and configure the tables and the columns and so forth, and play with the encryption of data and see the data encrypted inside the databases. And this is completely without setup. So this will give you a good, clear idea of how similar to a traditional SQL language the BlockBase is or provides as a service, right? And also, there's a growing list of resources on the BlockBase network site. So you can go there to BlockBase network /Explorer, and you can find all the APIs of the nodes and the language and the link to the online code and a lot of other resources about it. So this is how we are providing the adoption of the platform also. So guys, I hope you liked this short presentation about BlockBase and how it works. We're always available on Telegram and Twitter and Reddit and LinkedIn also. Those are our main networks. So if you've got questions, if you want to ask us stuff, we're there every day. We would love to talk to you. And I hope you guys reach us and continue viewing our future videos. And again, thank you for your attention, and catch you the next time.